Here are solutions to homework set number 4 for ECE 341 random processes. This homework set looks at binomial and uniform distributions. Now, assume you roll a 10-sided die and you win on a 1 or a 2, lose on a 3 through 10. So the probability of a success is 0.2. In that case, the moment generating function, or z transform, would be 0.8z plus 0.2. So 20% of the time I get 1 point, I win. 80% of the time I lose. Determine the probability of winning 4 times out of 10 rolls. That's a binomial distribution, which in general is in this form. I've got 10 rolls. I want to win 4 times. The probability of success is 0.2. Failure is 0.8. 4 successes, 6 failures. Multiply it all out, I've got 8.8%. Problem 2, determine the PDF when rolling the die 10 times. There's a couple options. One, I could use the formula for a binomial distribution, plugging in m equals 1 to 10. Second way is I could use convolution. With convolution, I'll set up a single coin toss as 0.8 and 0.2. So this would be the z transform. I've got my k-axis, or time axis, success axis. When k equals 0, I've got 0.8. When k equals 1, I'm at 0.2. So that's for a single die. Convolve that with itself, I have 2 coin flips. Convolve 2 and 2, I get 4 coin flips. 4 and 4, I get 8 coin flips. 8 and 2, I get 10 coin flips. So this is the result when I convolve 10 times. Probability of getting 0 points, 1 point, 2 points, 3 points, 4 points. And note that 4 points is exactly the same that we calculated in problem 1. 5, 6, 7, 8, 9, 10. So that would be the probability of 10 coin tosses. Either solution works. You can use the formula or you can use convolution. Problem 3. The National Oceanic Atmospheric Administration has been keeping track of world weather for the last 142 years. 27 of the last 30 years have been in the top 30 hottest years on record. So, let's see if that's just chance. What's the probability of any given year being in the top 30, assuming a uniform distribution? In that case, there are 30 years that are in the top 30, 142 years total, so there's p. And the probability of it not being in the top 30 would be 1 minus p. What's the probability of 27 of the last 30 years being on the hottest on record? Assuming this is just a random event, I've got 30 years, pick 27. This is p. P happens 27 times. 1 minus p happens 3 times. Multiply it all out. There's the probability. So this says that there is a chance that the weather is just random, that nothing's going on, it's just random fluctuations. The probability is 0.00000000001. Pretty small, but there is a chance. So if you're Ted Cruz and you want to say that there's no proof that global warming exists, technically he is right. Technically we don't know that we exist. We can't prove existence. And likewise, we can't prove 100% certainty that this isn't just random. It's 10 to the 13th to 1 odds that it's not just random, but it could be. Problem 4. This looks at a uniform distribution. With a uniform distribution, like a 6-sided die, the moment generating function, or the z transform, looks like this. These are the values you can assume between 0, 1, 2, 3, 4, 5, 6, and so on. The only numbers that can come up are 1 through 6. So these would be delta functions at the integers 1 through 6, and each has a height of 1/6. Add them all up, I get 1, and that's a condition of all probabilities. The sum of all probabilities has to add to 1. Something happens. This would be the z transform. So this would be 1 over z, 1 over z squared, 1 over z cubed, or written out as a polynomial in this form. That's for single die. Suppose you roll 6 dice and take the sum. Or if you're a D&D fan, that'd be casting a level 6 fireball. Determine the PDF, the mean and standard deviation, and the probability of doing 30 or more damage with a level 6 fireball. Now there's a couple ways of doing this. Probably convolution's the easiest. For a single die, this would be the Z transform essentially. I've got 0, 1 over z squared, 1 over z cubed, and so on. Convolve to 6-sided dice, I get 2d6. Convolve those two, I get 4d6. 4 and 2 gives you 6d6. So this is the PDF for 6-sided dice. If I draw a bar chart, here's what it looks like. This is the probability. This is the value. And notice this is a nice bell-shaped curve. That's the central limit theorem. Everything converges to this shape. We call that the normal distribution. A really important distribution we're going to study later. But anyway, for this problem, this is the probability of doing X damage with a level 6 fireball. To find the mean and standard deviation, the mean is just the sum of the probability times X. The variance is the probability times how far is X from the mean squared. So let's see. So the die rolls, the values are the numbers 0 through 36. Take the probability times the value, add them all up. That's the mean. So the mean of 66 is 21. The variance is the probability times the distance to the mean squared. The variance is 17.5. Take the square root is 4.18. And the mean and standard deviation are two important numbers. They kind of describe the normal distribution. Actually, they do describe the normal distribution. From the central limit theorem, everything converges to a normal. So oftentimes we want to know the mean and the standard deviation. The probability of doing 30 damage is just what is this guy at 31. The reason for 31 is MATLAB offsets everything by 1. So indice 1 means k equals 0, indice 2 means 1, 31 means 30. So the probability of doing 30 damage is 0.0098. The probability of doing 30 or more damage is the sum of all values between 30 on up, or the index 31 on up. 1.97% chance of doing 30 damage with a level 6 fireball. And the probability of doing some damage, of doing something, is 1. All probabilities add to 1. Problem 5. Instead of doing a level 6 fireball, suppose you cast a level 12 fireball. Determine the mean, standard deviation, PDF, and the probability of doing 50 or more damage. Well, I've got the PDF for doing 6. Convolve those together, I have a level 12 fireball. If I then plot it, here's what it looks like. Again, I'm seeing the shape over and over again. That's the normal distribution. If I want to know the probability of doing, if I want to know the mean, it's just the sum of the value times its probability. The average damage for a level 12 fireball is 42. The variance is 35. Standard deviations, 5.91. The probability of doing 50 or more damage would be, here's the probability of doing 50 damage. Here's 50 or more damage. And checking, all numbers add to 1. This is a valid distribution, valid probability function. Problem 6. The nice thing about convolution is you can do fairly hard problems. For example, suppose I roll 2 4-sided dice, 3 6-sided dice, 4 8-sided dice. Find the PDF, find the mean, standard deviation, and the probability that the sum is 40 or more. Well, this is again where convolution really comes into play. I can get the PDF, or the Z transform essentially, of rolling a 4-sided die. This just has the numbers. This is probability of 0, 1, 2, 3, 4. I skipped all the rest because they're all 0. 6-sided die, 8-sided die. I divide by 4, 6, and 8 because the numbers have to add to 1 to be a valid PDF. On convolve a 4 and a 4-sided die, I get 2d4. 6 and a 6 gives me 2d6. 2 plus 1 gives me 3d6. 8 and 8 gives me 2d8. 4d8. Combine these. I wind up with 2d4 plus 3d6 plus 4d8. Okay, and then if I plot the PDF, let's just do a bar chart. These are the numbers. Here's the probability. That's what it looks like. This is the PDF for rolling 2 4-sided dice, 3 6-sided dice, and 4 8-sided dice. Again, I've got that nice bell-shaped curve. Once again, that's the central limit theorem. The probability, or actually the mean is just the probability times the value, 33.5. The variance is the probability times the distance to the mean squared, 32.25. Take the square root. There's the standard deviation. The probability of doing 40 damage, probability of doing 40 or more damage, and the probability of doing something. So that is homework set number 4 for ECE 341 random processes with a binomial and a uniform distribution. I can use z-transforms or the moment generating functions to determine the probabilities, or equivalently, I can use convolution. With convolution, if I can get the probability into MATLAB, I can combine 2d6, 3d6, 4d6. I can mix dice. The PDF of 4-sided die, 6-sided die, 8-sided die, it's pretty much all the same. If I can get the PDF into MATLAB, with convolution, I can find out what's the probability of rolling 2 dice, 3 dice, 4 dice. And when I do that, I'm going to get a bell-shaped curve very often. We're going to see this over and over again. This is one of the distributions we'll be studying, called the normal distribution. Probably one of the most important distributions. We keep seeing it over and over again. So that's homework set number 4 for ECE 341.